What's up everyone? Welcome to part 7 of our YOLO tutorial series, and in this one we're going to continue with annotating our images. So in the previous video we looked at how to display the image, how to use a rectangle selector to draw a box around each object and get the coordinates of that box. Well, in this video we're going to write a function that takes those coordinates and generates an XML file to annotate the image. So what you see here is an example annotation file from the VOC dataset. And it's got a bunch of information like the folder it's in, the file name, the object or image size, height, width, depth, and then a bunch of information about the object, what class it is, what the pose is, and most importantly, the bounding box, which shows where the object is. So in this video, we're going to look at how to build a function to generate all this automatically. So let's get started. Alright, so in this video we're going to be writing a function that takes those coordinates of the bounding box that we draw and generates an annotation XML file. So for each image we need an annotation file, so we want to automate this process. So if you missed the previous video, make sure you go back and watch it, get the code from GitHub so you're all caught up. So I'm going to start with a new blank Python file in that same directory that we created, and let's start with our imports. So what we're going to need is OS, we're also going to need CV2, and then from XML we're going to be importing this thing called etree. So this is a XML library which we're going to need, and then from, well, we're going to import this other one called xml.etree.cElementTree. We're importing that as ET. So this is going to be our main XML generating library. Cool, so now what we're going to do is we're going to create a function and we're going to call it write XML. And now let's just take a look at an example XML file just so we get the basic structure of it. So again, I'm just going to pull up an example XML file from the VOC dataset. And first thing I'm going to do is collapse all these lower tags. So the main tag is going to be annotation, and then within it there's going to be folder, file name, and source and owner. For these two, we're going to skip them. It's basically just information about where the image comes from and who's the owner. It's not important for training, so like I said, we're just going to skip it. The size is pretty straightforward. It's just the width, height, and depth of the image. Then if it's segmented or not, which we're just going to leave it as 0 for all our images. And then finally, the object tag. So for each object in our image, we're going to need an object tag. And what it needs to contain is the name of the object, which is always going to be fidget spinner, the pose, which we're going to leave as unspecified for all of them, if it's truncated or not. And in this case, I'm going to leave it as 0. Obviously, there's going to be some images that are truncated, which means there's like something in the way, so a finger or a person. We might play with this later, but for now, I'm just going to leave it at 0. And also for difficult, I'm going to leave that at 0. And then finally, the bounding box. So this is going to be the coordinates of the box that we draw. So we're going to take all that information and write an XML file with all this information in it. So now that we've got that, let's jump back over to our Python file. So the things that we're going to need to save, we're going to need the folder. This is going to be the folder that we got the image from. Then we're going to need the file name. So in this case, we're just going to call it image or img. And we're going to use this to get the path or the file name to it. And also we're going to use it to open the image and get the shape from it. Then we're going to need a list of objects. So our object list, I'm just going to call it objects. Then we're going to need our list of the top left and bottom right coordinates. So that one I'm just going to call TL and BR. And then finally we need a path where we're going to save this. So I'm just going to call it savedr. So these are all the things that we're going to pass when we call our function. So now the next thing we're going to do is basically if the save directory doesn't exist, we're going to generate it. So it's going to be that same bit of code. If not, os.path.isdir, and the directory we're questioning is going to be the savedr. So if this doesn't exist, go ahead and make that directory. So make savedr. Cool, now that we've got that out of the way, let's get our object or our image name and the height, width, and depth. So what I'm going to do is create image, and it's going to be equal to cv2.imRead, and what we're going to read is the image.path. So this image is going to be a scander object, so we can call path to get the full path to it. Next thing we're going to do is get the height, width, and depth of the image. So the height, width, and depth is going to be image.shape. All right, so now we can get into the main part of the code of generating the XML file. So for the structure of an XML file, we can think of it as a tree, and each of those tags are an element or a branch of that tree. So the foundation or the root of it is going to be that main tag. So the main tag for us was going to be annotation. And what this is going to be is et.element, and the name of the element is going to be annotation. So this is going to be our highest level tag. Next, what we're going to do is add sub elements to it. So the way we do that is going to be et.subelement, and the name of the first one, well, actually, first thing we do is specify the higher level tag. So in this case, that higher level tag is annotation. Then we specify the name of this tag. So in this case, we're going to do folder. And if we want to specify what goes between those tags, we're going to call .text. We're going to set that equal to folder. And remember, folder is this folder. So it's just the name of the folder where the image comes from. All right, so that's that tag. And just to make things easier, why don't I go ahead and pull this up and put this to the side so we can collapse this. Yeah, so now we can see the structure that we're adding. So the first one we did was annotation. So I'll bring this up a bit. So we've done annotation, we're done folder. So the next one's gonna be file name. So I'm just gonna, let's push this over just a little bit so we get more room. So the next one's gonna be file name. So we're gonna call et.subelement. The thing that we're adding it to is, again, annotation. And the name of it is going to be file name. And the text in this case is going to be image.name. So this is the name of the image itself. Next thing we're gonna do, I'm just gonna push this a little bit farther over. Next thing we're gonna do is, like I said, we're gonna skip source and we're gonna skip owner. And let's go ahead and do segmented since it's a pretty straightforward one. So we'll do et.subelement, add it to annotation. This one's gonna be called segmented, and the text is going to be 0, but we can't give an integer, so we have to give a string, so it's gonna be a string version of 0. All right, so the next thing we're gonna do is we're gonna create this size one, and size is gonna have some sub elements within it. So in this case, we have to define size. So size is gonna be et.subelement. What's it gonna be a sub element of? It's gonna be a sub element of annotation. The name is gonna be size, and that's all we need to specify here. So now we're gonna start adding sub elements to size. So the way we do that, it's gonna be et.subelement. The sub element we're adding it to is size. The name is, for the first one, we'll do width. And then the text, well, that's gonna be the string version of width. And we're basically gonna do the same 3 times. So we're gonna do, this one will be the height, and we're gonna add the string version of the height. And finally, the depth, and this will be the depth. All right, so that's it for the size one. Now what we need to do is we need to add a tag, an object tag for each object. So since we can have multiple objects, we're going to need to loop over all our objects. So let's go ahead and do that. So I'm going to open up objects and just move it over a little bit. So now we're going to do a for loop. So it's going to be for obj, then we are going to call it top L and bottom R, and it's going to be in zip, and we're going to zip up the objects, the TL, and the BR. So remember what zip does, it creates a tuple, and there's going to be 3 values in each tuple. It's going to be an object, top left coordinate, and a bottom right coordinate. So we're going to loop over a list of tuples. All right, so we're going to come down here and we're going to create a new sub element for us to add stuff to. So we're going to call that one OB, and it's going to be et.subElement. What's it going to be a sub element of? Well, it's going to be a sub element of annotation, and its name is going to be object. Cool, so now we can start adding sub elements to it. So we're going to need name, pose, truncated, difficult, and bounding box. So let's start by doing et.subElement. It's going to be a sub element of OB. This one is going to be called name, and the text is going to be the OBJ. So in this case, it'll always be fidget spinner. All right, the next thing is going to be the pose. So et.subElement OB pose, and the text, we said it's always going to be unspecified. So capital U unspecified. For some objects, you might specify like they're facing left, facing right, but for us, we're just going to leave it as unspecified for now. And I'm going to go ahead and just copy this because we're going to be writing this stuff a few times. So the next one's going to be truncated, and the value is just going to be 0, so a string 0. Next one's going to be difficult, so we'll go ahead and put difficult, and again, it's just going to be 0. So now we get to the bounding box. So in this case, we need to create a new name. So we're going to call it bbox, and it's going to be equal to et.subElement, and it's going to be a sub element of OB. The name is going to be called BND box. Yeah, BND box. So now what we're going to add is xmin, ymin, xmax, ymax. So here we're going to do et.subElement. We're going to add it to bbox. This one's going to be called xmin, and the value of it is going to be the top left, but the first coordinate. So remember, top left is going to be a tuple, and it's going to have the x and y coordinate. So we want top L, but we want the 0. And since it's going to be a integer, we need to make this a string. So basically, we're going to do this 3 more times. So this one's going to be ymin, and we're going to take the second element of top L. This one will be xmax, and instead of top L, it's going to be bottom right, or bot R. This one is going to be ymax, and finally, this one's going to be element 1. All right, so that's it. That's everything we need to do. So we've created that structure. Now what we need to do is save the file. So before we save this file, we're going to do a little bit of formatting to make the file look pretty. So if we were to write this to file right now, it would just be one long continuous string. And what we want instead, we want those line breaks, the tabs, all that stuff. What that's called is pretty print. So that's the reason why we imported XML, so we can do pretty print. So I'm going to come down outside the for loop. I'm going to create something called XML String. And what this is going to be is et.toString. And what are we going to put to string? We're going to put that tree to string, the XML tree, which is annotation. Next thing we're going to do is create something called root, and root's going to be equal to eTree.fromString, and what are we going to take from string? The XML string. So this is where we use that XML eTree library for. Cool. Next thing we're going to do is redefine XML string, and this time we're going to do eTree.toString. So the whole reason why we went toString, from string, and then back to string, well, we're going to take that root and we're going to do pretty print is equal to true. So that's the whole reason behind it. We want to do that nice, pretty formatting. It just makes it easier, so when we're troubleshooting, we can see all the elements clearly without having to scroll. All right, so now that we've got this nice, pretty string, let's go ahead and just do a quick test to make sure we're getting what we want. So in order to test this, what we're going to do is we're going to return the XML string, and then we're going to come down here and write our if name equals main, and then just give it some sample data to check to see if it's working. So I'm just going to go ahead and copy this stuff so I don't have to write it all out. But you can see we need to call it, we need to specify a folder, an image, which is going to be a scander image, the objects list, the top right or the top left list, the bottom right list, and a save directory. And also just a quick note, I had a typo here, so this needs to be a string and this needs to be name. I had wrote image img.file name, so don't forget those. And I'm just going to close off this because we don't need it anymore. Then right below here, I'm going to create a folder. The folder is going to be images. That's where we stored all our stuff. Then we're going to loop over it, and then we're basically just looking in that folder, and we just want to get this image, basically the first one in the list. So we're just looking for something that has this in the name, and since it's going to return a list, we're just going to get the 0 element from it. Next, the object list is just going to be fidget spinners. Here's just some fake top left coordinate, some fake bottom right coordinate. The save dir, we're going to call it annotations, and then finally we're going to call our image, or we're going to call our function. So write XML, we're going to pass all this stuff, and then we're going to print this. So let's go ahead and run it. So here you can see we get basically what we want. So the annotation with a new line, folder, file name, segmented, and yeah, so it's kind of long. It prints it out like this, but because we have the new line elements, you'll see that when we save this to file, it'll be formatted correctly. So let's go ahead and write the code to save this to file. So before we return the string, what we're going to do is create a save path. So we're going to call it save path, and that's going to be equal to os.path.join, and what we're going to join is the save directory or save dir, and then we're going to do the image.name, but we're going to replace, in this case it had the extension PNG. We don't want that. We want the extension to be XML. So this is going to be the full path to the file that we're going to save. Next, we're going to do with open, and what we're going to open is the save path, and the way we're going to open it is going to be WB. So it's going to be, we're going to be opening this to write to it, and we're just going to say it's temp XML. Oops, XML. Then all we need to do is call temp XML dot write, and what are we going to write? We're going to write the XML string. So now let's go ahead and run this, and actually we can get rid of the return statement, and that means we can get rid of this and this, and let's go ahead and test this, see what we get. So we'll run it, it's finished. Let's pop this open, come to our annotation file, and you can see we have this XML file. So we generated the annotation, the folder, the file name, segmented, size, we've got the correct size. The object is going to be a fidget spinner. All of this stuff we just gave it default values. And then here's our bounding box. So xmin, ymin is 1010, and X max, Y max is 100, 100. So this is it. This is our function. So now we're ready to plug this function into our other file, which draws or displays the images and draws the bounding box. So let's go ahead and do that now. So now let's pull up our previous file, the one we used to display the images and draw the boxes. So that one I called draw boxes or draw box. So what we need to do is import our new function. So the file I called it was generate XML. So from generate XML, we're going to import that function which we called write XML. So now what we need to do is, instead of printing the values when we're done, we're going to write XML. So what we need to provide, remember, it's the folder, the image path or the image object, the object list, all the coordinates, and then the savedir. So the first thing is going to be folder. So if you remember, it was called, in here we called it image folder. So just to give you a quick reminder, our image folder was a constant called images. So we're going to pass that. The next thing we need is the image scanner object. So we called that img. And if you remember, it's a global, and here is where we're specifying it. So we're looping over our image folder, and each loop we get this scanner object called image. So we're going to pass that. Next thing we need is the object list. Then we need the TL list. Then we need the BR list. And finally we need the savedir. And if you remember, savedir was also a constant up here. And that should be it. So I believe that's everything we need. So I'm just gonna do a quick scan, and I think we're ready. So let's go ahead and run this. I'll save and run. We get our image, we draw our box, we hit the Q button, we get our next image, we draw our boxes, we hit Q, draw our boxes, hit Q, and you can see that our XML files are being generated. So draw the box, hit Q, draw the box, hit Q, and we basically just need to do this for all of our images. So depending on how many images you have, it could take a while. I've got when I did it with 250 images, I think it took me about an hour, because some of these images have a lot of objects in it. So it just takes time. Take your time, grab a cup of coffee, put on some music, and just sit back and draw boxes. You can see here's all our files that we're generating, and it's got those coordinates that we draw our box with. So yeah, this is how we can automate this process. This is what I came up with. I think this is, maybe it's not the best, but I think it's a pretty good way of automating and getting good boxes, because we're taking the time drawing the boxes, but we don't have to type in all those values. So I think that's going to do it for this video. Let me know what you guys think in the comments below. Leave a like if you liked it. And like always, the code's going to be on GitHub. You can contact me in the comments, or you can contact me through Facebook in the Facebook group. More than happy to chat and help you guys answer any questions you might be having. So we're going to need one more video to wrap this up. And in the next one, we're going to train our model. So we're going to look at how to modify the CFG file, how to specify or write the command to train it, and then we're going to look at how to test our results, how to load our trained models, load the weights, and test it on some real world stuff. So again, comments below, leave a like if you liked it, and thanks for everything, and I'll see you guys in the next one. Peace.